Hey guys, we are starting a new section, topic 20, which is on transformations. This is the first lesson, so if you are kind of just looking at this video, then rule off after the last work that you did, which should have been surface area and volume of 3D shapes. So rule off after that, you can write the date and you can get started. Alright, so in this lesson we're focusing on the first type of transformations, which are translations, but later on in the videos you'll see we'll also do reflections and enlargements and reductions. Okay, so a translation on a Cartesian plane is basically when you take a shape or point and you move it to another point, another part of the Cartesian plane without rotating it or reflecting it. It's literally just a shift. Okay, you basically just push it to another part of the Cartesian plane, and I'm going to show you how you do that with coordinates. Okay, so the first thing you need to know is that with translations, a translation only occurs when a figure is moved horizontally or vertically. Okay, so if you want to think about something moving diagonally, it would move up and to the right or up and to the left. So it never moves diagonally, it moves up and down, and it moves left and right. Okay, so it might look like it's moved diagonally, but it's actually just moved up and then or down and to the left, for example. All right, if a translation is moving to the left or right, it usually affects your x coordinates. Okay, so if I add a number to my x coordinates, so say I say I'm moving 5 units to the right. Okay, I'm adding 5 to whatever my x coordinate was. If I want to move left, I'm subtracting from my x coordinate. And then with vertical translations, if I'm moving up and down, it's affecting my y coordinates. So if I want to move up, I add to my y coordinates, and if I want to move down, I subtract from my y coordinates. Okay, so I'll show you an example of what that looks like. Okay, so here's my figure, ABC. Okay, the first thing you need to do is you need to figure out what your coordinates are. Okay, so if I'm looking at A, remember I start at 0 and I move across first, so I'm going to move across to -2 and up to 4. Okay, so my coordinate for A is -2, 4. For B, it would be the same. So I start at 0, I move across first, -1, 2. Same thing for C, I move across first, -4, 1. Okay, so I've got my coordinates for A, B, and C. It tells me they want to translate this shape 6 units to the right and 4 units down. Okay, you can do it just by jumping on the Cartesian plane. Okay, so 6 units to the right, which would mean that I need to add 6 to the x coordinate, and 4 units down, I would need to subtract 4 from the y coordinate. Okay, so these are all your x coordinates here. These are all your y coordinates. Okay, if I show it by just jumping, there it is, 6 units to the right and 4 units down. So technically, A should be translated from where it is to that point over there. Okay, so if you check it, my new coordinate for A, so I should be adding 6 to the x coordinate and subtracting 4 from the y coordinate. Okay, so that coordinate would give me 4 and 0. And if I check, if I move across to 4 and up 0, that's exactly where I am, at 0, 4, 4, 0. Okay, and if I do the same to all my other coordinates, so B is -1, if I add 6, I should be sitting on 5, and if I subtract 4 from the y coordinate, I should be sitting on -2, which is what I've got, and I do the same thing for C. If I were to now draw that on the Cartesian plane, that's where it would be sitting. Okay, so ABC has translated to A dash, B dash, C dash. Okay, so anytime that something is transformed to another part of the Cartesian plane, I always label it with a little apostrophe next to it. I call it a dash, so A dash, B dash, C dash. Okay, some people say A1, B1, C1. All right, let's do another example. Okay, so it says state the coordinates of R, S, T. So I'll just do R with you. I start from 0, move across first to 2, and down to -2, so my coordinate is 2, -2. Alright, so I figure out all the coordinates of these 3, and that's what I get. They tell me they want to translate it according to the following rule. Okay, so they say from your x coordinates you need to subtract 5. Okay, so from all of these coordinates you need to subtract 5. That means I'm moving left by 5 units because I'm subtracting. Okay, if I was adding, I would be moving right by 5 units. I need to add 3 to my y coordinates. So all of these I'm adding 3 to, and because I'm adding, I'm moving up. Okay, so if I'm adding to y coordinates, I'm moving up. If I'm subtracting from y coordinates, I'm moving down. Alright, so let's do the jump thing first. So I'm going to go 5 to the left and 3 up. Okay, there it is. I move 5 to the left and 3 up, so that would be my new r. Okay, so my new coordinate for r would be -3, 1. Okay, but you don't need to jump it every single time. You can just use your rule. Okay, so for s, I need to subtract 5, so 5 minus 5 is 0, plus 3, so -2 plus 3, that will give me 1. Same thing for t, I will get -1, -1. So those are my new coordinates, r dash, s dash, t dash, and if I draw that on the Cartesian plane, there it is there. Cool, that is how you work translations.